When you're building an observatory like the James Webb Space Telescope, you want to make sure all the pieces fit together correctly. To see how engineers go about doing that, we're here at Northrop Grumman in Redondo Beach, California.
We have two important pieces of our development hardware that we're putting together or mating today. We have our OTE mock-up,
Which is?
It's a representation of the optical telescope element. That's the part that has the big mirror and the cameras inside of it. And we're putting it together with the integrated validation article. That's really just the sunshield membranes attached to the space vehicle and the spacecraft part of it.
How difficult is this process? I mean, you have a crew of, what, nine people here?
That's right. We have 9 highly trained, highly skilled personnel here. The OTE mock-up weighs about 5,600 pounds, and we need to lift it very carefully so that we don't end up lifting it off level or having it swing uncontrollably. And we've got a couple of key pieces of equipment that are in the load train, that's between the hook of the crane and the actual thing that we want to lift, that are important to give us the information we need to do that lift safely. There's one thing called a load cell. That's actually kind of like a fish scale or a luggage scale, and that tells us how much we're pulling on the OTE mock-up and when we've actually lifted the entire weight. The second thing that's attached in the load train above that, it's that big black box that you can see up there. That's called a hydroset, and it's a little hydraulic ram that we can pump up and down and do extremely precise raising and lowering of very, very heavy hardware.
Now, this isn't exactly just like putting a couple of Lego pieces together. Your precision you mentioned, how precise do you have to be?
Right. Well, the interfaces that we're putting together are accurate to a few thousandths of an inch. We've got a little more leeway here with this development hardware, but still the overall process is the same and the care that we take to put them together is exactly the same.
So where are we now?
Well, we're right next to the spacecraft bus. It's called a bus because it carries the telescope and everything else, so it's a spacecraft bus. This is our mock-up representation of the bus, and we have in it one of our telescopic mid-booms that's built by Astro Aerospace. And this is not flight-like, but it does telescope out to the full flight width.
So basically the sun shield will be attached to this mid-boom and be stretched out.
Yeah, that's right. There's actually a spreader bar that goes in on the end. That's a big kind of pole-like thing. You can see them on the forward and aft sides. They're the big gray bars. There'll be one out here, and it will be attached to some cables that are attached to our membranes, and as the mid-boom pushes out, it'll pull the membranes out and unfold it. Okay,
Well,
so
let's see.
Let's get going. So we have this just on big tracks for ease of use on the ground. We don't need to actually have it deploy in a flight-like manner. We're just trying to get the motion correct so that we can check out our membrane. Now, the flight deployment doesn't go nearly this fast.
Yeah, I didn't think so. Well, thank you so much for allowing us to visit with you guys while you put these two major pieces of the observatory together.
Right. Well, it's an important event for us and a big risk burn down event, and we're just happy to have you out to record it for everybody.
The next step is for the sides of the sun shield to be folded up all around this telescope mock-up that I'm in to make sure that everything's in place during launch. Thanks for joining us for this edition of Behind the Web.